Yeah, recording has started. Hi everyone, welcome to the uh, uh, Pytorch to RAG, which is what we had titled our presentation series as. So obviously this is a uh, starting lesson. The last time we had covered the entire what is Python and what is various fundamental, but here we have to get into details how to use the Pytorch. First thing is the setup guide. There are various ways to set up the Pytorch. And what we have is the pytorch.org. There is a get started here, as you can see on the screen. We are not interested in Pytorch 2.x or, okay, let me not say Pytorch 2.x. We are interested in Python 3.8. Pytorch can be 2.x. So that's not a problem. So we are looking at this PyTorch and obviously the build, stable build we would like to use, and there are many ways to install. If you are a user of Ubuntu, then you can use the Linux with PyTorch build 2.6, which is available with pip. There are some people use Conda, especially if you are using MacBook and all. So it's a Linux variation, but you can do it with pip and the PyTorch. And obviously, you can use CUDA or you can do without CUDA. CUDA is the Computer Unified Device Architecture, which is the one used by the GPUs, especially those which come from NVIDIA. There are other example here is RCOM 6.2.4, which is one used by the what you call the AMD GPUs, and you can do even without the CUDA with just the CPU. So, and there are some Intel versions also which I am not referring here. It's not showing up here, but that will be with the x86. So, important point here I want to bring that when you set up your environment for the what you call the PyTorch, you need to go to some of the things which are important, and one of them I have shown is pytorch.org getting started, where if you are using a Linux OS, you can use this. If I use Mac, then it will be different example. If I use Mac, then you got pip and Python, and then it goes default. CUDA is not available in Mac OS. Please use default packages. So you may not be able to use CUDA if you use Mac. If you use Linux, you got CUDA 11.8 is the minimum. You can go even above 12.4, 12.6. And then if you do Windows, then you can use a Python with CUDA 11.8. And you can do with CPU also. Same way with Mac, it is default is with CPU. If you do Linux, you can do with CPU also without having to go through PyTorch. But of course, PyTorch libraries can be used, so it's not a necessity. But overall, installing on Linux, it has a CUDA support and it has got RCOM support. The prerequisites are stated here. This is we are taking for in the beginning itself we have marked, right? So we are looking for PyTorch with stable 2.6 you can install with CPU without CUDA. Why we are worried about CUDA or no CUDA is because CUDA means you have to use GPU. If you don't want to use GPU, there is no restriction. PyTorch has got the software library which can which can allow the parallel task to be executed even on the CPUs. Because if you have a CPU, quad core CPU with the superscaler and all that, some of the things even we can do without GPU, or we call it as XPU. So the combination what you want to use when you go to PyTorch or get started, you can look at what is the possible combination. The example I have shown you, PyTorch 2.6 with Linux, with pip, with Python, with CPU. Now I can change this. I don't want this. I want to use Conda. You can use Conda also. And Conda with CPU, and you can do with CUDA 11.8. But the default could be different. It depends on how you want to handle. Like example, we say we are interested in Mac. Now, can Mac be installed with Conda? But it has to be default. There is no compute platform with CUDA for MacBook. But if you want to Windows, you definitely can use Conda. You can also pip, maybe not, but Conda is definitely available. Also, you can do with libtorch some of them if you are using C++ Java. And if you want to do from source, you can compile it. So the options are available to you. This pytorch.org, why I'm showing is you can choose what you want. At least you know, because without setting up your PyTorch, there is no way you can do anything, correct? All the way, what we are trying to do is we are using a setup guide. So if you go to pytorch.org, you can decide what you want to do, and accordingly you can use whatever you want, like a Linux example, and with Python and with pip, and that is the default usually we use, and that gives you download the PyTorch, pip install the Torch version, Torch Vision, Torch Audio. So there are Torch has got a lot of uh, variation. One for visual, one for the audio. So speech, basically speech and text to speech, speech to text, video, etc., etc. So there are various ways to install. Uh, Only thing is, I would say that with all this respect to this, all you need is at the most, you can see what are the following are the support: Arch, Linux, CentOS, Debian, Fedora, Mint, OpenSUSE, PC, Linux, Slackware, Ubuntu, and there are minimums, and minimums are not really necessary. We should go with the best we can get, and usually 1804, 2004, and 22.4 is the more likely, and Python 3.8 or plus should be there, and you can go to the website and you can get the installation. Obviously, the other way to do is using Anaconda. Anaconda is very popular because that gives you the ability to do a command line installation, as well as you are able to use what is called as a Jupyter notebook. So you will see that you can installation with Anaconda, with CUDA, and no CUDA RCOM, but only with the with CUDA you can do, without CUDA you can do, with RCOM you can do, and with no CUDA, with CUDA, all combinations are there. You can verify which one you want to do. But important point is, if you do any coding and that code runs example either on a Google Colab or Jupyter Notebook, you need to import the Torch library. And example here he has taken for a random number generator. So import Torch, and then X is a random number generator. So torch.rand 5,3. So it has got some digits which it supply as an input to the random number generator, and it will print. So here is the output should be something similar to this. So if you do the simplest Torch, PyTorch is represented by Torch library in the Python. So import Torch, x equal to torch.random number generator, which is random 5,3. It's a seed, so you provide a seed and you print, and it gives you the output. So the output should something similar to tensor. So tensor is obviously a multiple, what do you call, when you say vector is one direction and one magnitude. If you've got multiple, you can have two dimension, 3 dimension, 4 dimension, n dimension vectors. So in this case, you have given 5,3. So it is 1, 2, 3, 4, 5 rows, and then you have got variations. That is, what is the value random number that it is generating, starting from some point to some point. So this is the random number generator, which is shows you that you can use PyTorch to generate a random number. Now the random number is just the simplest of the simplest. It's like a hello world of the PyTorch. Okay, so you can use similarly, check if CUDA is available under Torch, and you can say torch.CUDA is available, and then you can figure out if it is available. Then the prerequisite for the implementation using Anaconda is Anaconda or pip, either way you can use. These are the two utilities which are used. and you can say whether you want to get a NVIDIA GPU support or CUDA enabled or CUDA or RCOM enabled or otherwise, and the steps you have to follow, which is here given. Okay, so this is some of the important things about setting up, and I only described about setup guide. Uh, Usually when you do using github.com, there is a uh, simple thing. So what I'm going to do is, since I'm here, I can as well put in a chat window some important thing, and that is https colon slash slash github.com and then slash dv go, so dv go and then doy dbgod slash. So I'm going to give you a py and torch, okay, pytorch, and then I'm going to say step by step. So what I want to do is I want to give you a link, okay, and this link I'm going to click and share with you. So share this tab instead, okay. So you can see here, I hope you are able to see this. dvgodi pytorch step by step, okay. So this has got a lot of chapters, and the obvious intention here is to look at what are the various step by step. Starts with a chapter 0, 1, 2, 3, 4. So if I click on chapter 0, I want to show you that you got some code. So okay, so are you able to see the deep learning by Pytorch step by step, a beginner's guide? Are you there? Okay, so I hope I am able to. One sec. Nikhil, can you? Nikhil, Nikhil, are you there? Nikhil, please. Can
Yes,
you?
I'm here. Yeah, I'm here. Yes.
Just wanted to make sure that you are seeing the GitHub, uh, and
Yes.
and you are able to see the deep learning with PyTorch step by
With
step.
Pytorch. Yes. Yes.
So this is open source available to everybody. The idea behind this course is to follow this PyTorch step by step, a beginner's guide, so that you can use Google Colab. If you think you have Google, then you can use Google Colab. If not, you can copy paste this into the code which is there into one of those Jupyter notebooks, and you can go with the uh, code. So initially in the chapter 0, this is just showing that we can import NumPy, and what we can do through NumPy can also be done with PyTorch. So you know that we did previously Python and scikit-learn and NumPy are the two. So whenever you import NumPy, you name it as NP, and you take a scikit-learn, learn model, import learn regression, linear regression, and scikit-learn pre-processing as standard scalar. So you can do a linear regression, and linear regression is nothing but y equal to mx plus c, or in this case we have written y equal to b plus wx plus epsilon. Epsilon is the error, b is the what you call the bias, and ws is the w is the weightage. So a model is described y equal to wx plus b plus ws plus epsilon. So that is the generally you define a polynomial types where the output equal to function of input, the plus the bias plus the error. Now this is the uh, general gradient descent is nothing but if you have a uh, what you call a polynomial, and then the output you are trying to figure out, and you want to minimize the error, then how you go about the weights. This is nothing but your general way of convolutional neural networks, where in the neural networks you have different uh, layers, and each layer is considered as some polynomial, and then linear polynomial, and when you weight each polynomial with different weights and then different activation function, you can generate usually a set of layers, where the first layer is generally the one which is the input layer. More layers as you follow, they will be the hidden layers, and the finally classifier layer at the end. So this is for generally training and inferencing, which is what you use. The gradient descent is the beginning of that. So the gradient descent is generally you use for train and test, split, and then finally apply. So this is just a equation. You are taking a random, x is a random value, and then trying to get the epsilon, which is the error, and then you are trying to uh, calculate the output, which is you are trying to predict what is going to be the output, and then this you can validate, and you can run the set of inputs as arrays, as a vector, as we do in NumPy usually, and you can have a size. So example, here you got the data, and your input and output data you plot, and then you do some random initialization and try to figure out what is the optimum value, where the where the gradient is minimum, or uh, whatever the value is minimum. So you are trying to figure that out, and you can predict basically. So here, since we are talking about probability, because you got multiple data inputs, so you just say y hat is nothing, y cap or y hat. What we do, because train of x means you got x different x's, and for every x, what is the corresponding y you are trying to figure out. X is on the x-axis, y is on the y-axis. It's a two-dimensional, and so you are trying to generate a data train and validate that they are linear or they are non-linear. If it is non-linear, then how do you provide the weights so that you can replicate it, or at least optimize the error, so that you know, given x, what should be the corresponding y. And then since it's a train means you got I is I equal to 1 to n, or whatever that figure out to be. So you are trying to get a model, and you are predicting the minimizing the error, and this is what the mean square error is: 1 by n, I equal to 1 to n, error I square, and so which is nothing but estimated y versus the actual y and the prediction. So you are doing 1/n of it to ensure that it is averaged out. So mean, that is mean is 1 by n. Square of the error, that is you are taking the error, and the error square you are doing for every training input, and that's why this is predicted like this, and this can be shown. So the idea behind having mean square error is we call it as loss function. So basically the loss function should be minimum. If you minimize the loss function, then you get the optimum answer. So this is the implementation of this using some array, and you can see that sample is given, some data is there. So basically you have to follow the data and minimize the error and provide the uh, whatever the minimum. And so you can have, we can start at randomly at any point, because it is random. We have not said that it will be starting. Since you are generating a random, it could be a pseudo, but nevertheless it's a random number you are generating using Pytorch, so it provides you. You simply take the minimum and provide to get the loss surface to the minimum. So therefore, this is nothing but this is projected here with all the graphs and all that. So you can compute. Basically, this is nothing but because you got multiple data, and these multiple data, they are partially. So when you say gradient means partial differentiation, because you are the the differentiation occurs with respect to. So if you have y equal to mx plus c, you say that m is the slope. Now the slope you keep differentiating again second time, third time, fourth time. So you got uh, every time you do with respect to different uh, parameters, and therefore what we do is we say this is a partial differentiation. You want to minimize the loss function or the mean square error, and with respect to whatever the bias be, and this is equivalent to whatever with respect to y hat. That means whatever your output is, your output may be differ every time. So you are just defining that mean square error, the partial derivative of mean square with respect to the bias b is equal to partial derivative mean square error of with respect to the estimated yi, and multiply yi by b, so that you are just saying that you are differentiating. And to bring down that, that's why they are trying to equate and then say that this is 2 into 1 by n minus y hat minus yi. So estimated versus whatever actual is there. If you take 2 into 1 by n of that, that is how you get the number. So this is nothing but you are trying to compute the gradient for both b and w parameters. So b and w are the two parameters they have taken, and so you are saying that okay, print out, and you want to visualize it. When you visualize it, then you have to put some kind of a axis x and y, and then you project the loss function versus the function, which is your w function, right? So in this case, that is why they have put down that b, w, bs, ws all losses. So what is the loss function? If you minimize the loss function, you get the output. So they are calculating the w is nothing but weight. So b is nothing but a bias. Your bias and weight you are differentiating with respect to the mean square error and trying to get the gradient. And so this is what is the step-by-step input, and finally how what is the learning rate. If you take a bigger step, then it overshoots. So it may just fluctuate or oscillate, because when you have a con function which is either concave or convex, usually we say that is a u-like thing. So you try uh, randomly some number, and then try. If you try, it may overshoot or undershoot. So depending on that, your learning rate. If your weight, in this case example manual gradient, you got b bias is minus 2.9, whereas uh, that is the gradient is taken as 1.79. So the learning rate depends on this. So whatever numbers you choose for w and b, that so your learning rate is low if your what you call weight is on the higher side. If weight is on the lower side, then your learning rate will be uh, of course the learning rate is faster, but at the same time it may overshoot if your w is higher. But on the other hand, if w is lower, then your steps are lower, but then learning rate is slow. So whatever you have to choose between the two and optimize and get the output. So this shows you the loss function, how to optimize the loss function, and you are able to gather the information. And obviously after getting this, is we are using a numpy. This can also be done using Pytorch, so we'll come to that. But at this time it is showing that using numpy we were trying to do the plotting. After that there is a plotting, so you can see at the beginning what is the plot we have taken. Let's see what we have put down. The plot import Google Colab, import requests, and then you got config import and plots. You can see that from plots import star. So now scikit-learn, since we are using, we have got a different plotter. But if you do a Pytorch, there will be a different plotter. So whatever you are plotting import you are doing, that will decide how you plot, whether you do a Pytorch library for plotting or you are using numpys. Uh, and then based on that, you will get different graphs. So idea of the graph is to just to mathematically, instead of dealing with the mathematics, you want to see in pictures, which is much easier to grasp. And so models picturized as either mathematical implementation or as a graph. Graph gives you better pictures. So normally what we do is, assume I am a layman, I don't know about mathematics. All I care is, hey, I'll give this. This is the loss. I want to minimize the loss to this much, and my weight and this one, this is what I want to try. And you can try out and you can always change it, and you can see that as it goes, the stepwise training and stepwise prediction and classification, you will come to a conclusion that okay, this is better or that is better just looking at the graph. So train original, this training is bad, this train is scaled. So what it means is some scaling may be better, some scaling may not be good, depending on how the loss function is reached, how it is minimized. So you can see that you can rinse. Rinse means you can throw away everything what you did and repeat with a different, better starting point or better random. And then you can do a batch gradient. Batch means you can batch it together. A stochastic gradient you can do. So there are gradient descent different methods. You can do a batch, you can do a point by point, or you can do stochastic. So depending on what functions you are using to get the gradient descent, you can have a plot with different paths you can use and different methods you can use. So ultimately, idea behind this particular chapter, PyTorch, IPy and B, is to show that you can see the code also. You can preview or you can just use the code directly. You can see the code is here, and so cells are given, and you got the source, you got the markdown, and then you got the cell type, execution count, output, source, and all that. So all these are loaded directly. You just put it into your this one, and if you just want to check the detail about the code, just simply you can go and look into the code, blame or preview, whichever way you want to use. So this is the PyTorch step by step by Daniel Oigit Gordai. So that is why DV and then Godai. So DV Godai, Daniel Voigt Godai is the one who has provided this PyTorch step by step, and we will be following this to ensure that we are in having something in public, as well as having the codes available to us so that we can go and execute them. So that was the idea behind the GitHub, which I wanted to show, and hopefully you are able to get the link which is there in the, and we can follow that. So this is only one of the open source which we are trying to follow, but you can use PyTorch step by step anyway. All I wanted to share was to be able to, this is, we can go into, instead of chapter 0, we can go into other chapters. So let's look at chapter 1. Why chapter 1? Because obviously the preview we wanted to do with PyTorch, right? What we did initially was to do with NumPy. Now here you can see we are importing torch, torch.optim, optimization, top.nn, that is again the numbers, and Viz for the visualization. And so you can see that there are optimization, and there is numbers to crunch, and there is a plot, so dots and all that. So you can use various ways. Same project with same, what we did in 0 can be done with a different uh, indexes and different libraries. So this is providing a training and then values for validation. So you can use the same thing. Again, same thing is generated data validated. So I would like that you try through this. Chapter 0 and 1 you can try it together, because chapter 1 is based, 0 is based on the NumPy. Here it is mainly using PyTorch. So you can see how do you do the same calculation of the gradient descent, y hat, and you provide the training and you compute the gradients, and then you measure the errors, and then you take the mean of the errors. So all these are very, very simpler. If you do with PyTorch, it will be simpler. That's what it's showing. Updated parameters, you can have several parameters. See, if you are doing with Excel, it is easy, but then that only will work for 2, 3, 4 parameters. But if you have got hundreds of parameters, then it is better you do PyTorch based, because then you are just following the steps, putting it, and let the provider input feed with the training data, and generate the response and the error, and optimize and print. So here you can see that this is easier to do. That's what. So you got the expression called linear regression. So they called autograd. So there is a function called autograd, which is nothing but automatically uh, calculates the gradients, and therefore it's very, very popular that in PyTorch you don't have to struggle a lot like you do in NumPy. Just put the grad, autograd, put it in, and then you can do even tensor with no worries. So you can do scalar, vector, matrix, tensors, all kinds of torch you can have. There is torch. PyTorch has got different uh, generators, and you just have to use those generators, and you can use scalar, vector, matrix, all kinds of combination, and then it will do the job. So basically it means that the issue is this is all software implementation, and whether you want to do TensorFlow, whether you want to do vector, or whether you want to do 2 dimension vector, 3 dimension, n dimension, whatever, there is no limit on this. You can do metrics, you can do all computation. The issue is how do you speed it up. So the speeding up portion is what is either use CUDA or use some other method. It is not necessary that you have to use CUDA. You can do with a CPU, you can do with a CUDA, you can do with a RCOM, you can do with your own library, whatever XPU types. So basically, idea is not only that, you also have to worry about accuracy. That means, do you want to use the type as a float? Do you want to do a float 16, float 32, float 64, and whether you want to use the what do you call the uh, so basically in single precision, double precision, and then you do in a way where you got the mantissa and the exponent. Generally, exponential calculations are much easier to do with the PyTorch. So you can optimize instead of using huge ones, you can shift. So shift left or shift right. Generally, you do shift left, uh, then you are able to multiply, and so you can multiply, shift left or shift right, divide. So either multiply or divide can be done without having to really do much calculation, and that is where the idea is to minimize the calculation, optimize using exponential calculations are easier to do, and approximate log and all are easier. So there are certain things which are easy to do without having to deal with the GPU. That's why you will find that this uh, parameter creation and being able to do tensor without having actual tensor processor is worth looking at it. And therefore, this is autograd. You can see, as I mentioned to you earlier, autograd is very important because it does the gradient descent calculation for you very easily without having to do a lot of jugglery which you do normally in NumPy and all. So you got a b dot grad, w dot grad. You can calculate the gradient, and then uh, you can get to the error to minimize to zero. You want, you may get somewhere close to zero, and you can set what is the learning rate, and based on, in this case, learning rate is zero point 0.1. You can have learning rate of 1, but that's the maximum. So 0 to 1, whatever, in this case zero point 0.1, you can have zero point 0.2 also. So how fast you want, how many epochs. So basically what happens is when you run through one pass, it's called a epoch, and so you can do n epochs, and in the processing, to that is, you do a batch processing. You can have a batch, and you can go with the autograd function, and thereby you are able to get the. So the idea behind the uh, autograd with PyTorch is that you don't have to struggle with the learning rate and epoch and all that. It simplifies your work, and therefore you don't have to have a lot of mathematical background. You just know that you do a procedural way of doing it. That's the beauty of this PyTorch with dynamic computation, and you can do also graph and all. So you can uh, use the GraphViz is there. There are certain libraries available under this, and you can use those to do the uh, forward and backward computations, what we call in the numeral, what we call the convolution neural networks, or even for the deep learning. But generally, convolution neural network is the one which is standard. And then when you do deep learning, then you get into what you call uh, multiple. There is very big kind of uh, layers, hidden layers. So up to 10, 50 layers and all is fine. But if you go hundreds and thousands, then you, and maybe more, then you may want to do more of a what you call a dynamic this one. But otherwise, you can go with the zero grade, which is define some optimization, which is lower end. So the low rate is there. Okay. So learning rate is low, and thereby you are able to do it in a more precise manner. And epochs, number of epochs you can define thousand, so it will do 1,000 times, but it will come to a conclusion which is faster. And this is what it is. So you can calculate the loss function, and then you can do the predictions, and then you can obviously get uh, the random number generator is always required, because you better uh, start. We don't know where to start, so it is better to initialize with a proper random number. And there is nothing called proper. You just take a random approach and then see that the epochs which are there in the batch, it is able to contain it, and therefore you are able to do the linear regression, which is what the idea is. And obviously, we had already spoken about B and W, the bias and the weight. And then to wrap up, the number of parameters that you use, NN, which is what is the number of parameters. The lesser the parameters, easier it is. The higher the parameters, obviously you'll have to do more calculation. But as far as things are concerned, they are part of the static dictionary. If you're uh, doing something as, sorry, not static, state dictionary. So basically, dictionary in Python is the bunch of parameters that you use, and then as the value keeps changing, the weight keeps changing. They are part of the your dictionary variable, and which is what is used for storing the values. And then you can do a forward pass or a backward pass. Forward pass will give you a computation which is one way, and if you do a backward pass, then you can get the optimization, so that activation functions which are used, like relu or gelu, or there are many, and which is providing us the necessity, uh, what you call non-linearization of the linear models. So if you do a particular 0 and 1, certain branches can be suppressed with a 0 weight, so that they are zeroed, and whereas you can get the other one active. So you are actually changing the linearity and to non-linearity by suppressing certain uh, uh, tree, uh, what you call branches, and that's why you are able to optimize. So you can do a linear regression with n parameters, and then you can seed it. You can do a sequential mode. You can do layers, multiple layers, which is what is the neural networks combination. How many hidden layers you want, how many classification you want, and you can prepare the data. You can configure the model, and then you can train the model, and then you can ultimately run and then get the output. And you can get the uh, dictionary to provide you with the biases and whatever the values. So this is one of the methods. So idea behind this is only to give you a glimpse of PyTorch uh, as a step-by-step method by D.V. Goodeye, and we are using this, and we want to share this with you so that you understand that there is nothing which is not public. So you got a publicly available code. All you need to do is use your Jupyter notebook, or if you think you can use Colab. Colab is fine, but then you need a Google Gmail account. So, and plus the current state of Colab, I don't know. It used to be available and they have discontinued, I believe. So you will be better off using Jupyter notebook. And so that is our recommendation. And I think we'll stop here at chapter 1. And I think we will try, because this is the first time you are getting into Pytorch. Trying to do too much is not advisable at this stage, but I just wanted to make sure that you are. I'll so I'll go back to the PyTorch. Are you able to see the PyTorch?
Yes, yes.
So idea is you can go through the PyTorch.org, get started locally on your machine, and view the docs. There are many docs in this, and important is PyTorch documentation is available to you. And if you use the PyTorch documentation, it has got the PyTorch governance, build plus CI, PyTorch contribution guide, design philosophy, governance mechanics and maintenance and all that. And you can have developer notes are there if you want to do mixed precision, whether you want to use AutoGrad, whether you want to do broadcasting semantics, CPU threading. So the CUDA semantics are available as well as non-CUDA. I would put it as more like a RCOM, like semantics. Or there are other Intel semantics also available. It depends upon what exactly, like Windows FAQ is there. If you go this, you can use Windows FAQ, and how you can get the numerical accuracy by using floating single precision, double precision. What are the modules? Obviously, modules are the key for the Python any day. So building standard modules is the way. In PyTorch, AutoGrade is the most popular one, and you must understand AutoGrade. Obviously, with we also since we are moving towards RAG, that means we are moving towards the language models. So transformation is very important. So there are some neural network training models, building blocks, and example models of a building block, sequential blocks, right? So you got when you got the NN, which is the parameter, sequential parameters, and what functions, activation function you're using, ReLU example. Then how do you transform from one to another? So transformers are the key. Remember, that means what if you do text to speech, or text to text, or text to image, whatever you do, there is a transformation, right? So whatever transformation you use, those obviously the AutoGrad helps us to use uh, the gradient descent, which is most popular, and with the combination of ReLU functions or GLU functions, there are various function activation functions which make sure that if you, example, if you have 4 words and you want to predict the fifth word, how do you do it? So depending on what is common, what is uh, more frequently used and more likely. So it is a probabilistic approach. You can take it, or you can take it with a trained approach. So whatever your dictionary is, and so there are many methods. So it can be a dynamic or it can be static, and how do you want to go about? It's a different approaches are there, but at this time I would say, without getting into details, at this time you try to read the what do you call the various available advanced features we can go to later, like distributed training and parameterization, transforming and all that. But mainly a simple custom module and building block, and these two, if you can do using import torch and try to do a linear combination with a certain forward or backward implementation, so that you can have a input layer followed by a few hidden layers. You can have a tensor, or you can have a uh, array of vectors and whatever, 2D, 3D, 4D, because once you cross vector, it's all multiple vectors means you can call it as two dimensions uh, tensor, three dimensions, n dimensions tensors. So all are tensors. You can refer rest of them as tensors, not necessarily. It can be matrix also, but we generally tend to say two-dimension matrix and one dimension is vector and three-dimension onwards you put it into tensor. So everything is a tensor ultimately, but it's a tensor at lower level. So sequential is the way, that is when you do prediction you want to predict based on the what is the nearest likely keyword. So it's a word transformation. So that is for languages. If it is for an image, then there is an image. There are, if you want to cat or a dog, you want to figure out same way. uh, you can have all mission critical, business critical, all those kinds of predictions, training as well as prediction. So first part is you have to train, second part is you have to predict. So training and predictions are the key, and these are all approximation. So the accuracy means the loss function is important. So you try to minimize the loss function so that a cat appears as a cat and a dog appears as a dog. Or if you are doing something like a vehicle, a aeroplane versus a car, you are able to predict the car based on the features, vehicle based on the features. So there are many things. Similarly, when you try to language translation, let's say English to Hindi or English to Marathi or Tamil or whatever, or Tamil to English, and so whatever language input you give, you want to predict that what is the meaning of it. That is a translator. That is one of the way of uh, doing the transformation. So all at this time, focus should be on reading simple custom document module as a building block. I think at this time that one or two should be enough. Neural network training with modules that you can do as a third, as the next step. But I would say just simple custom module as building blocks. If you can do these two reading, that will give you the Pytorch view of doing things in a way. Of course, we can always go back, but at this time, I would say that we have. I'll stop sharing. I just want to make sure that you understood, and that's all for the day. So, what I have done is I have recorded. I'm going to stop the recording and then present this as your lesson number two, I would say. And later on, we'll see next week to be a little bit more deep dive into the step by step so that we can go into 0 and 1 we covered chapter. We'll go with 2 and 3 next time. So I'll stop here recording.